All right, let's just dive right into this. Welcome to this explainer. Today, we're taking a massive step back from your standard everyday football debates. We aren't going to sit here and argue about trophy cabinets or flashy highlight reels or, who has the best PR. Instead, we are going deep into the data to uncover a genuine mathematical mystery about human greatness. We are looking at the absolute extreme edge of sporting persistence. So the real question we have to ask ourselves is this. Statistically speaking, just how rare is Leo Messi? And what's really cool about this analysis is that we're shifting the focus completely away from those emotional World Cup narratives or the endless Ballon d'Or debates that totally dominate sports media. We're stripping away all the romance, all the fandom, and all the subjective opinions, and we're looking purely at his unprecedented statistical improbability. But okay, to do that properly, we kind of need to nail down what an outlier actually is. In data science, an outlier is basically an observation that diverges significantly from the rest of the values in a dataset. These are the data points that literally break your forecasting models. They don't just bend the curve, they exist entirely outside of it. And, as we're going to see, our subject today is pretty much the ultimate real-world example of this concept in action. To hunt down our outliers, we're leaning on some absolutely rigorous work by tech entrepreneur and engineer Diego Bash. He built a massive, comprehensive dataset covering everything from 1995 all the way to the present day, focusing exclusively on the top 5 European leagues. And the absolutely crucial detail here is the strict metric he chose to measure: non-penalty goals plus assists per 90 minutes. This is a super specific parameter specifically designed to measure pure, uninflated offensive output. By totally removing penalties, it strips away the noise and gives us a player's true open play value. And we really need to talk about the sheer scale of the data we're dealing with here, because it is massive. We aren't talking about some small, cherry-picked sample size just to prove a point. This dataset tracks 1,472 individual striker seasons and includes 101 long career strikers. We are grounding this analysis in almost 3 decades of the absolute highest level of European football. When you analyze a dataset this massive, the statistical noise just fades away. So when we find an anomaly buried in this mountain of data, you better believe it is mathematically ironclad. Now, here's where the math gets genuinely fascinating. You might think striker performance follows a normal, symmetrical bell curve, right? Like height or test scores. Actually, no. It follows what's called a gamma distribution. What that means is, while you have this massive clump of average players grouped together on the left side of the chart, the truly elite, record-breaking seasons stretch out into a very long, very thin tail that skews heavily to the right. Those elite seasons are incredibly, incredibly rare. Just how rare? Well, only 1 in 145 striker seasons ever reaches the baseline level that Messi simply averages. To put that into perspective, an absolute peak, mind-bending season by world-class players like Erling Haaland or Kylian Mbappe might touch this level for a single year. A single season at this level is an extraordinary achievement. It demands absolute perfection. But as the data shows, it's not totally impossible for a generational talent to hit it once. But this is where the fabric of statistical reality just kinda starts to tear. When we chart out the performance gaps at the top, we have Messi sitting up at the absolute peak, and then a massive empty void down to Mbappe. And what's completely wild here is that the gap between Messi and Mbappe is actually larger than the gap between Mbappe and the 5th best player. There is a complete unoccupied void between the top two. It's a whole bracket of performance that literally no one else has even touched in 30 years of football. And here is the ultimate plot twist of this entire analysis: the 1-year peak versus the 9-year plateau. Because his true statistical anomaly isn't really about how high he peaked. The real anomaly is his persistence in maintaining that absolute peak as a continuous plateau for 9 straight years. He essentially set up camp and lived permanently in a statistical stratosphere that the rest of the world's elite only ever get to visit for a cup of coffee. Let's actually break down what this 9-year plateau entails, because honestly, this might be the most shocking detail of all. Because of strict data completeness requirements, the evaluated window for this specific data set only starts in the 2014-2015 season. That means this window begins when Messi was already 27 years old. It completely excludes his physical prime. It even excludes his historic 91-goal calendar year back in 2012. What we're measuring here, the data that is literally breaking the charts, represents only his veteran years. Take a second and just absorb this number, 1.6 times 10 to the negative 12th power. If you calculate the probability of any 9 random seasons from this massive data set, combining by pure chance to create an average like his veteran plateau, well, that's your probability right there. That is quite literally a 1 in 640 billion chance.
Yeah, 1 in 640 billion. To put that kind of scale into your head, that number is actually greater than the estimated number of stars in the entire Milky Way galaxy. We are talking about a cosmic level of statistical improbability. This is exactly the kind of math you'd expect to run into when you're calculating the trajectory of deep space phenomena, not when you're tracking goals and assists on a football pitch. Now look, to be completely transparent with the data, we do have to throw in a quick caveat. Athletic talent obviously persists, right? Meaning a good player tends to stay good year over year. So these seasons aren't entirely independent random events like rolling a pair of dice. So practically speaking, it's not literally a 1 in 7 trillion player situation. But what the underlying math proves is something arguably even more profound. Out of 1,472 seasons, barely a dozen ever reached the level he averaged for an entire decade. His everyday baseline veteran performance is equal to the absolute highest, once-in-a-lifetime peaks of his greatest peers.
Okay, so with all that real data established, we've got to talk about the viral hoax versus the reality. A few weeks ago, you probably saw a chart going super viral online claiming Messi was a 5.9 sigma outlier. It was shared literally everywhere by major accounts, by fans, you name it, and it sounded incredibly impressive. But when you actually dig into the source,
you find some absolutely glaring issues. First off, the viral chart completely lacked a source or methodology. In fact, it was quietly deleted by its creator just a few days later. Second, it assumed a false bell curve, a Gaussian distribution, which, as we already know from the Bash dataset, is fundamentally wrong since elite football stats follow a gamma distribution. And third, it artificially inflated his true single-year peak, which is actually a 3.2 sigma. Just for context, sigma is just a math term for how far something deviates from the average. The higher the sigma, the crazier the outlier. The viral chart took his 3.2 sigma reality and pumped it all the way up to a 5.9. Simply put, it was fake math.
But man, the ultimate irony here, that fake chart totally exaggerated the wrong metric, his single-year peak, and somehow it still fell short of reality. When you do the math correctly and you focus on the right metric, which is his persistence over a decade, his true statistical anomaly actually sits at around a 7 sigma. The reality of his 7 sigma persistence is so much crazier and mathematically so much more impressive than the viral lie that everyone was sharing. I really want to leave you with this incredibly poignant quote from Diego Bosch. Younger people might see another Messi. Those of us with gray hair probably won't. It kind of puts everything into perspective, doesn't it? We've spent this explainer nerding out over gamma distribution, standard deviations in these massive data sets, but ultimately, it just highlights how incredibly lucky we are to witness this mathematical anomaly in real time. So the final thought I'm going to leave you with is this. In an era where sports science, data optimization, and elite academies are literally engineering better, faster, and stronger athletes every single day, will the math ever actually allow for a persistence like this to happen again? Thank you so much for joining me for this analysis.